In this video, we're going to solve a system of equations using the LU factorization of the coefficient matrix. Well, normally we express a system of equations as ax equals b, but in this case we've got an LU factorization for the matrix A. So instead of writing this, I'm going to write LUx equals b. And this is the system that we're trying to solve. Well, let's look first at u times x. If we take the matrix U, which is this guy right here, and we multiply through by the matrix that contains our variables, what we would end up with is just a single column matrix or column vector, and we might want to just rename that y. So why don't we say let ux equals y. What that does is that then simplifies the system that we're trying to solve. We're now trying to solve the little system ly equals b, and we know how to solve a system like that pretty efficiently. So let's say this is step one here, is just to rename ux, rename it y, and then we've got this little system here that we can solve. All right, so let's take a look at this system ly equals b. The coefficients come from this matrix here, which is L. I think I'll just label these L and U for future reference. So we're going to take our matrix L, and I'm actually going to write up the system in the form of an augmented matrix. So we'll just write our variables y1, y2, y3 across the top. And we want ly to equal b, which were our original constants in the system. So -3, -3, -45. Now, taking a look at this system here, certainly easiest to start solving from the top. The top row says that y1 equals -3, so I'll put a box around that. The middle row says that 2y1 plus y2 is equal to -3. And if we actually sub in the known value of -3 for y1, then we've really got -6 plus y2 equals -3. In other words, y2 equals +3. So we'll put a box around that. And our bottom row is saying 4y1 plus 3y2 plus y3 is equal to -45. If we now plug in both of our known values here, we've got -12 plus 9 plus y3 equals -45, meaning y3 is equal to -42. All right, so we may want to express this information just in vector form. The vector y is -3, 3, -42. Now for step two, we're going to go back to the fact that ux equals y. Remember, we're given the matrix U in the problem, and remember that we've just found the vector y right here. So we should be able to set up the system and solve. So step two, we're going to refer back to the fact that ux equals y, and just recopying from our previous screen, u was given in the problem. It was 211, 021, 006. And the vector y was the vector that we just found. It was equal to -3, 3, -42. So let's take this information here and write it up in the form of an augmented matrix. This time our variables are the x variables, so x1, x2, x3. U is our coefficient matrix. And this time it's the entries in y that are acting as our constants in our system. So there we go, there's our augmented matrix for the system. Now in this part of the problem, it's much easier to solve from the bottom of the matrix, since the bottom row is typically the simplest row here. Bottom row says that 6x3 is equal to negative 42. So that tells us that x3 is equal to negative 7. The middle row says that 2x2 plus x3 is equal to 3. And if we plug in our known value, that x3 is equal to negative 7, then we've got 2x2 minus 7 is equal to 3, meaning 2x2 is equal to 10, and x2 is equal to 5. Now going up to the top row, we've got 2x1 plus x2 plus x3 equals negative 3, and this time we're going to plug in both of our previously known values. x2 is 5 and x3 is negative 7. So this tells us that 2x1 is equal to negative 1, meaning x1 is equal to minus 1/2. And last thing we need to do is just write up our answer in vector form. So the vector x, which was our ultimate quest in this problem, vector x is minus 1/2, 5, negative 7, and that is our final answer.